The remainder and factor theorem, this interesting lesson is totally depends on dividing polynomials. We have two ways to divide polynomials. The first way is called the long division. And let's say we have the following question: 9x3 minus x minus 3 is divided by 3x plus 2. The procedure is 9x3, I'm gonna put it here. Since we don't have x to the power of 2, so I prefer to put 0x2 minus x minus 3 divided by 3x plus 2, you can put it here. The procedure is the first, I'm going to divide it by the first. So 9x to the power 3 is divided by 3x. 9 divided by 3 is 3. X divided by x, we minus the exponent 2. And the answer, we have to put it up there. After that, I'm gonna multiply the answer by everyone. So 3x2 multiplied by 3x is 9x to the power 3 plus 3x2 multiplied by 2 is 6x to the power of 2. And I prefer to say change the signs instead of minus them. Adding polynomials, 9x3, 9x3 cancel each other. 0x2 minus 6x2 is negative 6x2. About the rest, we put them the same. The procedure is repeated once more. Negative 6x2 divided by 3x. Negative 6x2 divided by 3x. Negative 6 divided by 2, negative 2. Divided by 3, negative 2. X divided by x, x to the power of 1. So minus 2x to the power of 1 up there. And also multiply by everyone. So it's going to be negative 6x to the power of 2. Negative 2 times 2, negative 4x. The same thing, change the signs. It becomes positive, it becomes positive. Adding, we got 6x2 minus 6 plus 6x2 cancel each other. Negative x and plus 4x is 3x. And about negative 3, the same. As long as the exponent is equal or greater than, we keep dividing. Once the exponent is less than, we stop. So once more, 3x divided by 3x, and the answer is 1. So plus 1 up there, and multiply, gonna be 1 times 3x plus 2. Change the signs. 3x minus 3x cancel each other. Negative 3 and negative 2 is negative 5. Assuming x has exponent 0, less than x exponent 1 up there, so we stop. This is the remainder, and since the remainder is not 0, then we can say that 3x plus 2 doesn't divide 9x3 minus x minus 3, or it's not a factor. This is called dividend and this is called quotient, and this is called divisor. So how to arrange the answer, or what is the relation between dividend, quotient, divisor, and remainder? The relation is given as dividend is equal divisor multiplied by the quotient plus remainder. There is another way, but I prefer this way. So the question, the dividend is 9x3 minus x minus 3 is equal, a divisor is 3x plus 2 multiplied by the quotient. The answer is 3x2 up there minus 2x plus 1 plus the remainder is negative 5. The second way of dividing polynomials is called synthetic division. And the following question is given: 2x4 minus 5x2 plus 5x minus 2 divided by x plus 2. And the procedure for synthetic division is depending on the coefficients only. So I'm going to put to the right 2, which is the coefficient of x4. Supposed to have x to the power 3 next. We don't have x power 3, so it's a must to put 0 here, otherwise it's going to be wrong. And negative 5, the coefficient of x power 2, and 5, and finally negative 2. To the left, I assume that x is equal negative 2, so we put negative 2 to the left. For the first step, the first number, we take it down the same. And then we multiply negative 2 by 2, and the answer is here. Negative 4. Plus the two numbers above each other, 0 and negative 4 is negative 4. Repeat, negative 2 multiplied by negative 4 is positive 8. Add them, negative 5 and 8 is positive 3. Multiply again, negative 2 by 3 is negative 6. Add them, 5 plus negative 6 is negative 1. Multiply again, negative 2 times negative 1. The answer is positive 2. When you add them, you get 0. The last number ever is the remainder. And these numbers, 2, negative 4, and 3, are the coefficients of the quotient. Our question, the highest degree is 4, so the quotient, the highest degree is minus 1. So you're going to start your quotient with x to the power 3. So this is 2, the coefficient of x power 3, negative 4, the coefficient of x power 2, and 3, the coefficient of x, minus 1, so this is the quotient. As mentioned earlier, dividend is equal divisor times quotient plus remainder. So our question 2x exponent 4 minus 5x exponent 2 plus 5x minus 2 is equal, its divisor is x plus 2 multiplied by the quotient 2x3 minus 4x2 plus 3x minus 1 plus the remainder, which is 0 or no need. I need your attention for the next one. Also using synthetic division, 10x to the power 3 minus 13x to the power of 2 plus 5x minus 14 to be divided by 2x minus 3. For synthetic division, you have to make sure the coefficient of x is 1. So what we have to do is, I'm gonna divide everything by 2. The question turns into 5x to the power 3 minus 13 x to the power 2 divided by 2 plus 5 over 2x minus 7 divided by x minus 3 over 2. In this case, we can apply the synthetic division. Assuming here x equals 3 over 2. So arrange the numbers, 5, negative 13 over 2, plus 5 over 2, and negative 7. To the left is 3 over 2. The first number is the same. Multiply 3 out of 2 times 5, which is 15 out of 2, plus them. Negative 13 plus 15 is 2 out of 2, which is 1. Multiply again. 3 out of 2 times 1, 3 out of 2, plus them. 5 plus 3, 8, divide by 2, 4. Multiply. 3 out of 2 times 4 is 12 out of 2, which is 6. 12 out of 2, which is 6. Plus them, negative 1. As we said, the last one is also always the remainder. The coefficients of the quotients are 5, 1, and 4. The question has degree 3, so our quotient must have degree 2. So we're gonna have x exponent 2 and then x. The coefficients are 5 plus 1 and plus 3 plus 4. So this is the quotient. Arrange the answer. So dividend is 5x to the power 3 minus 13x. So you want to keep this, or you want the first one, is up to you. So let's take the first one. the one before we divided by 2, so 10x3 minus 13x to the power of 2 plus 5x minus 14 is equal to, its divisor is 2x minus 3 multiplied by the quotient 5x2 plus x plus 4 plus the remainder, which is negative 1. The best application of the lesson is the factor theorem. This theorem allows us to factor a polynomial. So let's have the following question. F of x equal to x3 minus x2 minus 41x minus 20. And we need to know the following binomials, x plus 4 and x minus 5 are factors of this polynomial, and to find the missing factor. To know x plus 4 is a factor, we have two choices. Either the direct substitution, what we call a synthetic substitution, and in case after replacing x equal negative 4 we got 0, it means x plus 4 is a factor. Or using synthetic and long division, and we can judge according to the remainder. So we have two options. The best one is to use synthetic, so I'm going to use synthetic division. 2, the coefficients, negative 1, negative 41, and negative 20, and the number is negative 4, as we mentioned earlier. 2, bring it down the same, multiply, negative 4 times 2, negative 8, you add them, negative 9, you multiply again, positive 36, when you add them you get negative 5, when you multiply again you get positive 20, when you add them you get 0. The last one is the remainder, and since the remainder is 0, this means that x plus 4 is a factor. Similarly, to check x minus 5 is a factor or not, we replace x equal 5, or we use again synthetic division. I'm going to use synthetic division. And the good thing about this way is no need to go back for the question itself. I take the depressed one, which is the result I get from here, 2, negative 9, and negative 5. And we need to divide it by positive 5. 2 is the same, multiplied, you get 10, add them, you get 1, multiply, you get plus 5, when you add them you get 0. So again, the remainder here is 0, which means that x minus 5 is also a factor. So both of them are factors of the function f of x, And to find the missing factor, it is already given here. Two x plus 1 is the answer of the division of the polynomial by the two factors x plus 4 and x minus 5. So f of x can be written as the two factors x plus 4 and x minus 5 and the missing factor is 2x plus 1.